On behalf of Unicom, I would like to welcome you all to today's webinar on Enterprise Information Management. The webinar is presented by Mike Ferguson, who is the Managing Director of Intelligent Business Strategies Limited. With over 33 years of IT experience, Mike has consulted for dozens of companies. For today's webinar, Mike will take questions at the end. Also, we will be running a 3-day Enterprise Information Management seminar with Mike in London on the 26th of February. Without further ado, I will hand over to Mike.
Okay, mate, thanks. Good afternoon, everybody. Thanks again for taking time out of your busy schedule to come along to this. I want to spend a little bit of time just going through what it is that's driving companies into really investing in enterprise information management as a core competency going forward, and look at some of the issues that need to be addressed here, with a view to hopefully, if you're interested in this particular topic, clearly, it'd be a great pleasure to see any of you on the on the seminar, the workshop that I'm doing with Unicom at the back end of February. But it's just a little bit about me. Want to reach me or tweet. My background is as a regular database administrator. Then in the sort of mid-80s, I co-founded Cod and Date with Dr. Ted Codd and Chris Date, inventors of the relational model. I worked there for a number of years and then went off to Teradata in Los Angeles to become a chief architect on their product strategy and architecture team before becoming an industry analyst about 20 years ago. And I work internationally. Well, I'm based here in the UK and work a lot of the time here in the UK and in mainland Europe. Okay, so this is what I'm seeing in a lot of organizations today. More and more complex data landscape occurring. If you just look at transaction processing systems, it's still the case that many companies have multiple lines of business. They operate in multiple geographies, and the net result is that they may end up with multiple duplicate applications in those different geographies. And when processes execute, there's multiple copies of data. Data has to flow between those systems, and ultimately the number of connections between applications can be very significant, kind of FTP mania to some extent. And the result is significant complexity around the links that go between those applications, and if any of those applications changes in any way, perhaps a new release, for example, then there's a big chance that a lot of these links will break. Now, of course, many organizations trying to address this with service-oriented architectures and so on, but nevertheless, it's still a major problem. But it's more than just the transaction processing side of it with duplicate data and sort of duplicate processes and duplicate applications. If you look at the analytical world, the trend there is towards multiple data warehouses, multiple data warehouse appliances. We're showing 4 different appliances here that are emerging in many different organizations. So it's no longer a case that one of these exists, it's multiple exists, and so there's islands of analytical data, often with duplication of data across them, particularly when it comes to dimension data like customers and products and assets and suppliers and those kinds of things that are used to analyze and put metrics in a particular context. So we're dealing with more data stores in the analytical world at the moment. If I look at master data, many companies are still in a situation where they don't have MDM implemented, or maybe it's partially implemented, but it's likely to be the case. I'm just using a banking example here, that you could have multiple data entry systems where subsets of master data could be being updated through multiple disparate transaction processing systems, and the net result is that those subsets may overlap. They have different identifiers for the same data. Different data names and definitions exist in multiple different applications, and there's just various degrees of inconsistency potentially across them. Every time I change data in any one of these systems, I typically have to tell all the others, and so there's a huge amount of work goes on just to keep applications synchronized so that processes don't break. Big data is now on the scene. I'm very active in this space with a lot of my clients, and what I'm seeing now is multiple data stores just around big data. So going beyond just the data warehouse appliances we saw a moment ago, now what we've got is other kinds of data stores running analytical workloads. Hadoop as an example. We could have graph databases. We could have stream processing systems where we're analyzing data in real time. And so we've got multiple different analytical data stores, and those SQL databases, in the case of graph databases being an example there. So there's more complexity there. And then added to that, we're also now, excuse me, many organizations are in a hybrid situation where some of their applications are inside the corporate firewall on premises, and some of them are now out in the cloud. And so it's making data more fractured, more distributed, but yet it still has to be managed. So what we've seen so far is multiple duplicate transaction processing applications, an increase in the number of analytical data stores in the form of appliances, additional data stores around analytical workloads associated with big data, and now even more distribution of data on-premise and in the cloud. And there's no question there's a growing investment in the cloud in a lot of organizations. And of course then you add unstructured into the mix, and unstructured data is scattered to the wind. It could be on multiple file systems, it could be on content management systems, it could be in SharePoint, and so a whole range of different systems where that data may currently reside. So it's not surprising that business users are struggling. The pressure here is to remain agile, and yet at the same time data is becoming increasingly more distributed. And so people are struggling to find and access the information that they need in order to do their jobs on a daily basis. And my opinion is this is set to get worse as the number of data sources increases. More and more data is coming in from outside. We're on the edge of seeing the Internet of Things appear, where the number of data sources could explode by a serious order of magnitude and make it far harder to reach more and more data from so many different sources. And the pressure is being felt. If you take a look at this survey done of 1,700 chief marketing officers, it shows that they're all saying, the whole data explosion is really a concern to them, and they really don't feel prepared for it, certainly underprepared for it, and it's sort of impacting their ability to kind of get on top of the insights they need and be able to reach the people that they need through the appropriate channels. So it's a big challenge going forward in marketing, let alone in other parts of organizations. Now, so the question then is, well, if that's the case, what have we done about it so far? And of course, we've had data warehousing and BI for some time now, master data management, cloud computing, big data, all happening. So I want to briefly look at these and see what's going on. If you look at data warehousing and BI, well, we're well down the track, 20 plus years now, but in reality, the idea of a single enterprise warehouse hasn't happened in a lot of organizations. We've ended up with multiple data warehouses and data marts in different parts of a company's value chain, and so that's often grown up on a project-by-project basis. That makes it harder for people like managers to be able to look across a value chain and be able to report on overall performance, to perhaps understand supply and how it meets demand, or vice versa. And so getting an integrated view across their value chain is pretty challenging. It may also be the case that you've got inconsistencies across data warehousing systems, perhaps different data definitions for the same data in multiple data warehousing systems, and primary keys for the same data. It really depends on your investment in enterprise-wide standardization of data versus project-oriented systems that have grown up on different funding with different development teams. So it's not surprising, given that that's the case, that people using self-service BI tools are having to access multiple data sources, and the concept of multi-source data integration, I think, is now the norm in many organizations. And in fact, if I'm honest, my opinion at the moment is self-service BI could become a major threat to data governance going forward. What we've got here is, because there's multiple disparate data warehouses, there's other data sources like personal data like Excel, access databases, other systems where people need to pull data in where they haven't got it in a data warehouse. The net result is that we're pushing integration onto business analysts and expecting them to do it. They're often doing it on self-service BI tools, but you've got, in some cases, the ability to do lightweight data integration, sometimes referred to as data blending. But the bottom line here is that we're starting to move into personalized data integration, or personal data integration. Every user is starting to do this. It has the potential to spiral out of control. It's not that they want to do it, it's they have to do it because the number of data sources that are out there is growing. But the chances are that this whole initiative could destroy data governance if there's no investment in common definitions across all of these systems, if there's no reuse as opposed to reinvention going on, and potentially inconsistency could reign as a result. So to me, it's getting control of governance and lineage and everything that users are doing in this environment is very, very important. As I said, ungoverned self-service BI can have a very major impact. Could even cause data chaos because of the fact that people are having to integrate data from multiple sources to answer the questions and produce the dashboards they need. They could be creating inconsistent data definitions. They could be integrating data differently from the next person. And therefore, two different dashboards supposed to show the same result may show different results because of different users doing different things to the data in order to integrate it. So there's a potential, potential for major increase in the proliferation and overlap of data sets going on in a self-service BI environment, multiple versions of that, and if we are not careful, data chaos, if there's no ability to know what they did to the data in order to integrate it, and if we can't share those kinds of things going forward rather than have users reinvent things which have already been integrated by others. So to me, this is a bit of a warning flag at the moment. On the MDM side, well, a lot of companies have gone down this road, maybe to do single domain master data management. Maybe it's for product data, maybe it's for customer data. Might even be that they've used disparate systems, different master data management products for different entities. A lot will depend, but fewer have gone the whole hog and gone to enterprise master data management, where we have multi-domain hubs, common ways to integrate, common data definitions everywhere, common ways to synchronize, common master data services. It's much more challenging to get to this kind of level of implementation, but nevertheless a very important goal to improve business processes. Cloud, as I said, the relationship there appears to be relentless. We're moving to more and more cloud-based applications, whether those are HR applications, CRM applications, ERP applications, and so we're farming some of the transaction workloads out onto a cloud-based environment. And so the net result of that is that it's harder to integrate data, and no question you have to do that. Maybe it's to integrate data from on-premises systems to provide to the cloud, whether that's to cloud transaction processing systems or to cloud-based business intelligence, or the opposite way, that is to integrate data from the cloud with on-premises data to perhaps build a on-premises data warehouse, or to supply data to other transaction processing systems in-house in order to allow business processes to execute across multiple applications and data to flow with it. And of course, if you're trying to access this kind of hybrid world, then we'd like to hide it and make it easier to access. And so data virtualization is a way in which to do that, albeit that a lot of companies haven't invested in data virtualization to date and have just forced the job of integrating the data to the business user and saying, well, you deal with whatever data you want to integrate and handle it yourself. On the big data front, a raft of new data sources emerging, probably clickstream being the most popular, but we're starting to see emails and social media data coming in, sensor data coming in, all of which are relatively new data sources, some of which are unstructured. We don't know what the structure of the data is. They don't fit easily into a predefined data model, and many of these systems are, many of these data sources are unmodeled so far. And what's emerged in the big data scene is more complexity now into multiple analytical workloads, some of which work on data warehouses, some don't. So we've ended up with multiple analytical systems, which can include Hadoop, NoSQL databases, other analytical relational databases, perhaps to build statistical and predictive models to be used elsewhere, even live streaming analytics to analyze data in motion before it's even been stored anywhere. So we've got multiple platforms and therefore a more complex, if you like, analytical environment to deal with. If you look at this chart, it kind of shows that there's a whole range of different data integration paths emerging within that ecosystem. Besides supplying data into Hadoop or into graph databases from Hadoop, doing MDM, of course, and traditional warehousing still going on, moving data from data warehouses into Hadoop or from NoSQL databases into data warehouses or vice versa. So there's a whole raft of things going on here. These are probably the most popular paths. Now, what I've seen in my clients so far is that these different projects are growing up kind of independently. Some team working on analytical models for streaming analytics, others working on a project associated with big data like Hadoop, other ones working on data warehousing, another one working on maybe analytical appliances to have 4 or 5 power users build predictive and statistical models, and then we've got maybe a NoSQL analytical thing going on as well in a graph database. And so we've got different tools managing the data and integrating the data for each kind of analytical data store. And so if you take all of these things, cloud situation, the Hadoop, the data warehousing, data virtualization, MDM, all of it, essentially what I see is we've got a lot of project-oriented silos emerging. The cost of data integration and data quality is higher than it should be. There's a potential for inconsistent data definitions across all of these systems. It's slower to develop because we're reinventing rather than reusing. And the metadata lineage across all of it's not necessarily there. And so the net result of this is data management, governance, and quality.
Hi everyone. Sorry, we seem to have lost audio. We'll just see if we can get back in contact with Mike. Hello, Mike. Hi, Mike. We seem to have lost your audio. Yeah, hi everyone. We seem to having Mike seems to be having a bit of problem with his audio. I think he's going to be reconnecting. If you give us a few minutes, we hopefully be able to sort it out.
Or flowing out to the different applications involved in a business process, then the chances are people, if it doesn't flow and it is inconsistent, then it slows down the process execution. The process may stop at points you didn't expect it to stop. People have to get involved, and because of that, it means less automation, higher cost of operating, slower process execution, maybe unhappy customers as a result. So the kind of data that needs to get governed and managed in an EIM program, can be structured, semi-structured, unstructured. Doesn't mean you have to manage absolutely everything. It does mean, however, that you have to decide what it is that you want to manage and govern. And so we're at the point today where it's no longer just a structured data only thing. So the scope of an EIM program can range from on-premise systems, systems on the cloud, and any movement of data between you and other businesses. It affects your transaction processing systems, your data warehouses, master data management, reference data management, any data virtualization, any data flowing over an enterprise service bus or a messaging backbone within your organization, any data flowing between applications in process data flows. Doesn't really matter whether it's an ESB or some other mechanism that you flow data between applications. It's still impacted, and of course it also impacts the data entry, whether we enter data at a keyboard, whether we enter it through electronic messages coming into the enterprise, or whether it's files coming in. All of it is impacted in scope when it comes to EIM. As I said already, we have to introduce governance into data management disciplines, everything from naming data, to modeling it, to managing the data quality and integration of it, the audit and protection of it to make sure that it's secure, that it's data privacy is protected no matter where it goes, and even being able to relate unstructured content to structured data. So you need some kind of strategy around EIM, and that involves, putting in place goals and projects in order to get your data under control. Means having the right operating model to be able to govern data. It means that we have to standardize the data, you want to manage it, put processes and policies in place, and very importantly, have a methodology, a systematic approach to getting this data under control, as opposed to everybody doing things differently across multiple places. And of course, technology, we need technology to help us get the data under control. And in terms of an operating model, this is the kind of thing I'm seeing working well in organizations where you have multiple data governance control boards working on different kinds of data. It could be master data or transaction data as shown in this example. And then there's an enterprise data governance control board as well, but most importantly, in all of these data governance control boards, there's dispute resolution process, a way to solve problems where there's disagreement. The only thing I can say from my own experience is disagreement is normal, and therefore we can handle it fairly easily in a less stressful way if there's a formal dispute resolution process if there's disagreement. And so getting that to work within your organization is very important. Because at least it then means that if we do disagree, we have an easy way to, well, let's say a formal way to resolve it and move on. We need a methodology as well. This is the one that I use, starting off with defining common definitions, modeling data using those definitions, discovering where your data is out there, mapping the data you find out there to your common definitions, and then profiling the data you find out there to see what shape it's in. Is it in good shape, bad shape? And if it's in bad shape, then you know what to clean it up and integrate it and provision it in a state that's fit for business use. And once it's provisioned, you can then monitor that and make sure it doesn't deteriorate in quality, protect it if there's sensitive data in there, and secure access to it. Of course, this methodology needs to work with software technology to help you implement the stages of a methodology like this. Metadata is created each of the steps in this methodology and needs to be shared across the tasks involved in this kind of approach. And ideally, you're looking for technology that has a tool for every one of these individual tasks in order to help you implement this whole thing. We need data standardization. We have to get common data definitions for our data in order to get it under control, and that often means a business glossary is a technology that's needed. That's a business user tool as opposed to an IT tool, and so we very absolutely need business involvement in the defining of the definitions around data. And why do you want it? Well, we want it to be able to produce trusted data. People sit looking at screens not really sure what data means. If we had standard definitions, there would be somewhere to go to understand what it means, somewhere to go to say what data exists in the enterprise about customer, about product, about orders, whatever it is. We'd have a capability. So a business glossary is typically part of an enterprise information management technology platform, a suite of tools that share metadata. And ideally what you want is the combination of the methodologies and the EIM platform of technology work together in order to be able to build data warehouses, build MDM systems, provide data for analysis into big data environments, provide data for information services and data virtualization, and to provide it as it flows through enterprise service buses. So you want a common suite of tools to be able to do that. We also need reference data to be managed, and by reference data I mean code sets. For example, code sets exist all over the place, and we need to be able to discover all the disparate code sets that are out there. It could be currency codes, country codes, all kinds of codes. I'm showing an insurance example here, catastrophe codes being an example of that. And ideally you would want to release, if you like, formal versions of that reference data to be supplied and synchronized across all systems to keep them in sync. We also need to introduce a common approach to managing data across a more complex analytical ecosystem, which includes both traditional data warehouses as well as big data. And rather than have every system with its own data management tools, that could range from standard ETL to all kinds of other smaller tools that could be used. What we're trying to do is have a common approach to populating these systems and moving data between them during analysis. And we can't forget about sensitive data as well. You know, data may be considered to be very sensitive and therefore at risk. And clearly there's been plenty of examples of security breaches of late that can not only damage your brand but can also lead to other terrible consequences like identity theft, those kinds of things, and making sure that we can protect and audit everything that goes on with regards to data across all of these platforms is now a major concern for a lot of organizations. I mean, just look at the headlines that have gone out over the last few years. I mean, there's some damaging stories that have hit the press that just, you know, you'd rather not, you know, avoid altogether. And so parts of that EIM tools also have to be able to deal with data privacy masking, to deal with data encryption, to deal with retention and archiving and ensuring secure access to data no matter where it goes. And so we have to deal with the challenge of information security as part of an EIM story that includes looking at the data landscape, includes looking at the applications, whether those are on-premises applications or cloud applications. It includes managing data in a development and test environment. Sensitive data should not be able to be viewed by software developers that could easily be sort of contractors or power users that, you know, could abuse their power if they have access to that data. It should be handled even in that environment, so we have a separation of duties that's needed. Users, of course, as already mentioned, need to know who those users are. It affects both, you know, the enterprise systems and mobile systems that we're dealing with. We have to comply with regulations. This is a tall order to deal with this problem, including lots of different policies that we have to implement. We have to remain compliant. Policies to be able to handle privacy, encryption, to be able to mask the data, to be able to audit it, monitor it, detect any problems, take actions. And we have to be able to implement changes, and when we do implement changes, we want to know that it hasn't caused or isn't likely to cause a security breach, so that we can you know, have confidence to move forward as changes are made. So this is a challenge, and it means in the case of big data, for example, that we have to now take security to a far lower level, down into the APIs themselves, to be able to understand what applications, map-reduce jobs, graph analytics jobs, stream processing jobs are all doing to the data. As well as what's going on in traditional SQL environments. We need to understand that, be able to audit it. And so part of the EIM tool suite that I've spoken about already includes the ability to encrypt or redact, in the case of unstructured data, or mask any kind of sensitive data across this entire ecosystem. We need the tooling to be able to do that and monitor it, rather than bits of tools that might do some of it that are, you know, very disparate and more complex to manage and implement. So the question then is, on the basis of all of those things I've discussed, is your data out of control or not? You know, I mean, how good a job are you doing here? Do you have metadata under control? Is there lineage? Do you have data quality problems? Have you got a lot of inconsistent data across multiple systems that it's duplicated, fractured, and is a real challenge to keep under control? Have you got lots of standalone BI systems? Have you got an increased usage of self-service BI with individual users defining data and integrating data now? Do you know what they're doing? Do you record the metadata as to what they're doing? Do the tools that you've implemented in a self-service BI environment even collect metadata as to what they're doing? Is that undermining what you're doing centrally in IT on enterprise data governance? What about MDM? You know, you've got master data under control. Do you understand where master data is maintained across your systems, where it's, you know, where it has to flow to in terms of synchronization? All of those kinds of things. And do we have a situation where your unstructured data is kind of scattered to the wind? I mean, the bottom line here for me is that enterprise information management is about systematically getting data under control. It's about reuse. It's about common, consistent definitions, about common and consistent policies to transform and integrate and clean data, and reuse of data integration so that we don't reinvent wheels and inadvertently cause inconsistency across the enterprise, whether we're building master data systems, whether we're building data warehouses, or whether it's just on, on-demand data integration or self-service BI users. So with that, I mean, these are the issues that I want to discuss, and that I've got methodologies that help you get that data under control in your own organization. And if you are interested in this and are struggling with this and want some strong methodologies and approaches to dealing with this, I'd be grateful if you join me on the Enterprise Information Management Workshop that we're doing 26 to 28 February in London with Unicom, and be great to see you there. So at this point, I'm going to see if we can take any questions.
Yeah, thank you very much, Mike, for your webinar. Yeah, we'll just wait for people to write their questions down, and I'll just assign them to you as they come.
Okay.
Okay, there's a question.
Okay, so the question is the continuous improvement approach that I shared sounds quite sensible. Given the set of challenges, do you see an industry framework emerging? There are methodologies out there, a good one being Mike 2, for example, that is kind of being, I suppose, adopted. But the bigger disappointment for me is that there's no joined up thinking at the moment around, okay, they've got enterprise information management vendor tool suites, good examples being Global IDs, Informatica, IBM, their Infosphere platforms, SaaS with the Dataflux tools, Oracle, SAP with a lot of their business objects, data management tools, and others, Pervasive, for example, or sorry, Actin as they are. The only thing to be said here is that there's also threats to that. Big data is still delivering lineage, Cloud Era starting to deliver lineage into their Navigator software on the CDH platform on Hadoop. That's not joined up yet. Similarly, the biggest concern I have is that self-service BI vendors are introducing data blending and maybe recording what business users do, but the idea that there's any standard there to share metadata, unfortunately I haven't seen one. So I think there's still potholes in the road, but it's a great question, and I don't think we've got a completely joined up framework as yet. Okay, the second one is, are there any KPIs for measuring the success of an EIM project? Yeah, there are. Most of them are around data quality, I would say, more than anything. Which could be things like fill rates or various other kinds of measures that are associated with the actual data themselves. But I have to say, I am somewhat concerned about the fact that we could have a runaway situation emerging in self-service BI, and with business users, they have a need to integrate data because the number of data sources is climbing, and like it or not, they have to integrate data. It's not that they want to. because they have to, but as the self-service BI vendors add that capability to make it easier for people to integrate their own data, frankly, I don't think that there's any measures going on in a self-service BI environment to know whether the consistency is being measured or not. I mean, I know that vendors like ClickView, for example, have got data governance capabilities within their tools. You know, and I know other vendors are starting to implement lineage to record what end users do. But what I am seeing is a kind of enterprise data governance thing going on, which is IT controlled, whilst at the same time that's kind of being almost bypassed by self-service BI users. And so it's almost like, well, we're getting it under control, but it's a bit like chasing the end of the rainbow because you think you've got it right, and then you find that the business users are off doing their own thing. And I think, you know, that there's, you know, if I'm honest, I think, you know, success with EM has to come from managing data from both ends, from the center out and from the outside in. And I think the trend at the moment is towards outside in. That is to say, where business users are integrating data and doing what they want out there, and then are making it available to IT to kind of clean it up and make it enterprise-wide. And so, rather than going the other way around, so I think we've got a problem on our hands, which can be solved, but I think it requires us to manage the data from both ends. It's not enough to just do this from the center in an IT environment. We've got to do it from the business units with the business analysts as well. Okay.
Yeah. Thank you, Mike. I'm sorry, Mike. Sorry.
Go ahead, please.
Yeah, it's just, yeah, thank you, Mike. It's just we're running out of time as well. So if any of you guys have any further questions, just feel free to email us directly, and we'll forward them to Mike. And also, thank you very much, Mike, for this excellent webinar. And I would like to thank everyone on behalf of Unicom for attending this webinar. And thank you very much.